Nice to see you all. My name is Barr. I'm the CEO and co-founder of Monte Carlo. Monte Carlo is a data reliability company focused on helping enterprises increase trust in their data by eliminating data downtime. I'm really excited to be speaking at the conference and share with you a glimpse of what data downtime actually is, why I think it's the biggest problem that the data industry is facing today and how it will grow in its importance, and some tactics that best-in-class data organizations use to address this, including data observability. Really looking forward to it. See you all there. Hello, everyone. Welcome to the last session of today. I hope you had a great day full of inspiring talks and interesting conversations. Welcome. My name is Barr Moses. I am the CEO and co-founder of Monte Carlo, and I'm looking forward to speaking today about the rise of data downtime, how to make observability a pillar of your data strategy. I personally believe that data downtime is one of the biggest challenges, if not the biggest challenges, that the data industry is facing today, and one that will actually further increase in its importance in the future. And to that end, we should be talking about it and thinking about it more than we are today. I'll walk you through today specifically what is data downtime, why you should care about it, how using software engineering best practices can actually help us manage data, and what that actually looks like in practice for your data environment. So I hope you leave this talk today with maybe a few kind of new things and maybe one or two sort of practical tips that you can take and actually implement in your own organization. Really looking forward to this. If there's any questions throughout the talk, please feel free to pop into Slido. Looking forward to deep diving after this. So just a little bit of background about myself. As I mentioned, Monte Carlo, we are a data observability company. That means that we help enterprises trust their data by minimizing data downtime. Prior to Monte Carlo, I was actually VP at a company called Onsite, which is a customer data platform. And at Onsite and previously to that, I was fortunate enough to work with some of the best data organizations in the world, helping them with their data strategy and operations. My background is in math and statistics. And just a fun fact about myself, I'm a huge fan of action movies, particularly Bruce Willis action movies. There's also some amount of good math in them, particularly in the movie Die Hard 3. If you haven't had an opportunity to check that movie out, there's actually a math problem that Bruce Willis solves there involving jugs of water. So fun fact about me. With that in mind, let's get started. Start talking about data downtime and what data downtime actually means. So as I mentioned, I think data downtime is something that's been prevalent in the data industry and is taking even more of sort of an increased importance in our everyday lives. What does that mean in our everyday lives? So if you're all attending this conference, you must be working with data, and perhaps you see yourself in one of the personas that I'm sharing here. Perhaps you are Reliant Rebecca. You sort of really sort of work a lot with spreadsheets. Potentially you are helping teams like marketing and product to make decisions based on data. So spend a lot of time running, perhaps cohort analysis to better understand which of your customers are succeeding and which need more help. Perhaps you see yourself in Analyst Anna. Analyst Anna is called the SQL queen at her company, and she really sort of nails everything SQL. She works closely with the financial team and the data analyst folks to help glean insights from the data. And perhaps you see yourself in Engineer Emerson, who works regularly with BigQuery or Snowflake, who sort of works with Python or R and does data modeling, potentially even some ML engineering. And perhaps finally you see yourself in Manager Michelle. Manager Michelle uses reports like Power BI or Tableau or Looker to really manage the business and to make decisions and to report to other executives on how the business is doing using data. There's obviously many other personas in the data space, but there's really one common thing for everyone on sort of in this persona and in this conference. We all have this shared experience of data downtime. We all experience periods of time when data is wrong, and this is something that is sort of is a shared fate for the industry. Let me tell you a little bit about how I personally experienced data downtime. So in 2016, I was actually responsible for an organization that was responsible for our customer data. And on a regular basis, what was happening was we were sort of using this data to make decisions, but we would wake up in the morning to hear from someone else, someone downstream, potentially, an executive, potentially the marketing team, potentially the customers of our company, telling us that the data is wrong. Perhaps sort of something sort of changed in the report. Perhaps a table was not updated. And back then, I was really sort of asking myself, how is it that I always hear about this from someone downstream, right? Like, why are we the last to know? And if you're like me in the data industry for a while, you must have experienced this. I don't know if it sort of brings memories of waking up at 2 a.m., sort of sweating because you're delivering a big presentation tomorrow, and you're sort of fingers crossed that the data will stay accurate until then, or potentially it's just a few minutes before a big meeting when you're going to report on sort of the new digital product that you just released, and suddenly all the numbers don't make sense and you're not sure what happened and why. Everyone sort of has their own bad data or horror story and experiences with these kind of sort of data problems. And they're frustrating and they're hard, right? As folks who sort of pride ourselves for the accuracy and integrity of our data, it really, just sucks when downstream consumers tell us that data is wrong. Zooming out of sort of our personal experiences, there's also sort of, quite significant implications on our company when this sort of happens, right? I was talking to, a big algo trading company that mentioned that one small schema change that someone made upstream actually resulted in the loss of about $10 million in 1 week because of this kind of change that had unintended consequences downstream and didn't get caught for an entire week. Or a retail company, that because of sort of missing credit card company was put at compliance risk, which is very significant these days. And then finally, I was speaking with an e-commerce company that mentioned to me, for us, our main product is actually our website. And so when the data on our website is wrong, it's actually as bad as the entire website just being down. And why is that? That is because when consumers or customers use our products or use our websites and the data there is wrong, there's a strong erosion of trust, right? And so, while we can be working on sort of other activities that drive revenue or other activities that can help move our business forward, we are actually inadvertently creating this erosion of trust with our customers, when it's exactly the opposite of what we'd like to do with our data, right? We want to create more trust. And the interesting thing about this is that when data does go wrong, it creates this flywheel effect where someone says, this report or sort of this data set actually looks pretty wrong to me. There's something off here. And then immediately someone else is like, well, you know what? If this data set is wrong, who knows? What about all these other data sets that are wrong, right? And then someone else says, well, if all the data is wrong, then let's just resort to kind of knowing what we know best, which is making decisions based on our gut. And it just creates this kind of flywheel that continues to reinforce itself. And so, I think, how do we stop this flywheel, right? As a data industry, how do we face this reality? Some statistics to help support this and to, kind of bring to life, what does this mean for each of us? And why does this matter, right? Like, why should we care about this? Whether it's sort of significant financial impact that our companies incur. It sounds like from research from Gartner, it's about $15 million annually on lost revenue. Whether it's 1 in 5 companies that actually have proven to have lost a customer because using inaccurate information about them. Or finally, we talked a little bit about sort of teams' time. I personally remember when when we were hit when with kind of a fire drill or sort of learning that particular data set is wrong or something like that. It took us anywhere between days to weeks to figure out the root cause, and we needed to understand like what exactly in the system broke down and what were the changes that resulted in this. And so, data teams or data organizations end up spending a very significant amount of time actually troubleshooting and trying to understand where data breaks, so to speak. In fact, the HBR reports that analysts can spend up to 80% of their time actually dealing with these issues that are related to missing, erroneous, or inaccurate data. So it's definitely taking sort of a toll on all of us. Here's the good news. You're not alone. At a minute there, I wasn't sure if it was just me or everyone else. And actually, I talked to, at this point, hundreds of data organizations, some of the best data organizations in the world, and learned that everyone is facing data downtime. Everyone is facing instances when, data is wrong, when they're sort of the last to know about it. And it really affects companies from very small startups to large Fortune 500 companies, and affects across industries from fintech to healthcare, to retail, to tech, and many others. Just a specific example, recently, COVID-19 reports were inaccurate because of out-of-date data, right? And what could be more important in these days? I was speaking with sort of a VP data at a large company, and he mentioned to me, I really see sort of this the importance of data downtime as a keep out of jail card for my CFO, right? We really need to make sure that we sort of have a handle on this, because it's so pervasive, and it really impacts everywhere. So let me get to the meat of it here. I've been saying the word data downtime for a while now, but like, what does it mean, right? It sounds good, but like, what does it actually mean? Well, the definition of data downtime, the definition proper, is periods of time when your data is partial, erroneous, missing, or otherwise inaccurate. Where does the term data downtime actually come from? It's actually a corollary to application downtime. So what does that mean? If you think about it, a couple of decades ago, folks were running their businesses on, potentially, let's take an example of their website, right? And maybe 20, 30 years ago, just the beginning of having websites. And, honestly, if your website was down for a little bit, nobody noticed, right? Some folks were looking at your website, maybe some were not. And in those instances, when, when your app was down or your website was down, it just wasn't a big deal because there wasn't a lot of dependency on it. But today, that kind of sounds ridiculous, right? Like, who can be running a business with their website going down regularly, right? In fact, there's this massive industry that has emerged to make sure that your apps are always up and running. And, solutions like New Relic, App Dynamics, Splunk, Datadog, these are all tools that help us make sure that our applications and our website is up and running, and that we're minimizing application downtime. I think the same thing is happening in data. So today, if some of our data is wrong in some instances, or potentially, we're off by a small percentage in some areas, maybe it's not a big deal. Maybe we can get away with it. Maybe we can make a decision based on somewhat wrong data. Maybe we can feed wrong data into a machine learning model and be okay with it. Maybe in some areas, maybe we can cut ourselves some slack. I don't think that in the future, in a couple of years from now, we're going to be able to continue to do that. There's no way that as we rely on more data and we have more consumers of data, that we're going to be able to get away with data downtime. It is so pervasive, and we are relying on more and more data in a way that just doesn't allow us to have sort of this to live without this rigor in place. And so, in the same way that we've developed methodologies to deal with application downtime, I'll talk a little bit about what are the methodologies to deal with data downtime today. And so sort of the first step in that direction for how to actually deal with data downtime, as I mentioned, is sort of actually we can leverage best practices from an existing industry that has solved this, which is namely software engineering. In fact, this is why software engineering was invented, to solve these kind of problems. And so let's take a quick tour into the world of sort of software engineering principles that help make sure that applications are up and running. Let's take a quick tour there and then see what can we leverage from that space to help us better manage data downtime and data reliability. So taking you all a little bit for the world of software engineering, let's talk a little bit about DevOps observability in particular, which is observability in software engineering. So engineering's leverage principles of reliability and observability to make sure their applications are performing as expected and that uptime is very high for the application. So there's like 5 nines of availability, right? What has driven this? Well, as organizations, tech stack have become more complicated over the years, potentially moving from monolith to microservices architecture. DevOps team, as a result, needed to maintain a constant pulse on the health of their systems, which complexity was sort of ever growing. And so observability speaks up to the instrumentation of these systems, the monitoring, the tracking, and the triaging of incidents to actually prevent downtime of applications to begin with this. And as a result of this sort of industry-wide shift that has happened to distributed systems, which are more complex to manage, observability engineering has emerged as this fast-growing engineering discipline. At its core, observability sort of goes through or sort of is broken into kind of these 3 major pillars, which you see here. The first is metrics, which refer to some sort of numeric representation of data that's kind of measured over time. The second are logs, which are a record of context regarding, a record of an event that took place in a specific timestamp. And finally, you have traces, which basically represent these events in a distributed environment. Now, every engineering that respects itself has some solution, like I mentioned, like New Relic or PagerDuty or Datadog, in order to sort of to instrument, monitor, and measure these. And the question is, why are data organizations flying blind, right? Why don't we have something like this to help manage our data and our data down? Well, I'm proposing that we actually change that. I'm proposing that we actually can apply the same best practices of DevOps to data pipelines. And like DevOps, to use instrumentation and automated monitoring and triaging to identify and better evaluate the health and the quality of our data, with the end goal of having healthier pipeline, more reliable data, and more productive teams. And so what is data observability? Data observability is an organization's ability to fully understand the health of the data in their system, thereby eliminating data downtime. Sounds pretty straightforward, right? Who wouldn't want to understand sort of the ability to health of your data? Sounds way easier than said, right? So how do you actually make this a reality today, right? Like, what does this actually mean in practice? Let's spend a little bit of time on that with some specific examples. So how do we sort of, start by taking observability, which is a very well-known and understood domain, certainly for the last couple of decades, and how do we then apply that to data, right? In observability, it's very clear sort of what you need to track. It's very clear who tracks it and with what solutions. But what about data? What can we do in the data space? Well, here is sort of kind of our first take at what are these data, what are sort of the core pillars of data observability in particular. And let me explain how we arrived at these or where these sort of come from. In the same way that applications can break for a million different reasons, there's still an agreed upon set of metrics that everyone sort of agrees on that you need to measure and look at in order to understand the health of your applications. In data, similarly, you might ask yourself, well, data can break for a million different reasons, and there could be thousands of different root causes for why my data is wrong. It could be a schema change somewhere. It could be, incomplete data that has arrived. It could be a third-party external source that send data late. It could be that the data has arrived, but it is full of nulls or duplicate values, right? There's so many different reasons for why data can go wrong. How are we able to, or how would we able to have sort of one holistic way to kind of define these? Well, we've actually sort of, over conversations of sort of hundreds of data teams at this point, we actually asked all of these teams, like, tell me about your data horror stories. Tell me when data breaks, why. Tell me what were the symptoms that you knew that you had a problem. And then tell me what was the root cause for those problems. And we've taken that entire data set and basically used that to classify these 5 data observability pillars. And I believe that together they bring sort of this power of observability to data and give us this holistic view. So I'll walk through each of these and what these actually means. So the 5 are freshness, distribution, volume, schema, and lineage. Let me walk through each and give a particular example to bring this to life a little bit. Just a second. Sorry about that. Let me see. Okay, we might just skip the freshness example here. I think this is not loading, so let's go directly to, sorry about that. We're just going to skip over. Maybe this was due to data downtime. Who knows? Here we go. Okay. Can everyone? I think you can see. Perfect. Okay, and we're back. Awesome. So I'm going to walk through each of the different pillars and give a specific example. So this is the first example for freshness in particular. So freshness refers to the availability of data and to understanding whether the data has arrived at the time that you expected. So what you see here is actually a screenshot from a particular table, and at each line that you see here is actually a particular time in which the table got updated. And so the system here detected that the table is getting updated in particular intervals. You can see each of these bars here. And then in a particular amount of time, there was this large gap during which the table did not get updated. And so the system picked up that in this case, there might be a freshness problem. So this is just one example of sort of a freshness issue, but freshness can include sort of a number of different metrics around the timeliness and availability of data. And it's one of perhaps sort of the biggest culprits of data downtime. So often, we are using data that's actually out of date, and it's one of sort of the most common traps of data downtime. And so having ways to understand, when is my table, when is my data supposed to get updated? Is it supposed to get updated 2 times an hour or 5 times a day? Does it get updated more regular particular seasons of the year? The ability to know when exactly is this data last updated and when should have been last updated is the key to understanding freshness. The second pillar, which is distribution, speaks to the values of the fields themselves. So in particular, it helps us understand the distribution of fields. In this case, there's been an identification of a higher than regular percentage of null. And so, in this case, there's some data that you're expecting to get at 0.6% null, right? Then suddenly today, 99% of the data is null. How often, who's encountered something like this, where basically sort of the job was completed, the data arrived on time, it's all there, however, it's full of nulls, right? And potentially the only way you learn about that is from something downstream. In this case, by tracking the percentage of nulls, we can actually understand, when the distribution has changed. And under sort of distribution, there's many different things that you'd want to count, that you want to look at. Null values, unique values, et cetera. Many different sort of types of statistics about the data. Third pillar here is around the volume of data. So as I mentioned, making sure that the data is arriving on time, it has, the right sort of characteristics that you expect, and also that it's the right volume, right? So if you're getting way more, rows than you expect or way less, that obviously sort of indicates a problem. And there's different tactics and metrics and strategies to get at it. One of it is number of rows that have been removed that you're looking at right now. And so, if you expect regularly to have between, a couple thousand row removes, and then suddenly, you have sort of 10,000 row removes or even 10 millions, there's clearly a problem here. The fourth pillar is schema. Excuse me. And schema speaks to really sort of the organization or structure of data. Schema is often also the culprit of data downtime. Typically someone will make a schema change somewhere, potentially change, a field type from float to string, or potentially, removed or actually deleted a particular field. In those cases, if you're not unsure of sort of all the kind of the downstream implications of that, this might actually result in data downtime. And so automatic tracking of this is one of sort of the core pillars of data observability to really make sure that you're sort of on top of like how your data changes, and who's responsible for them. And then the last point, or sort of the last sort of pillar of data observability, is lineage. And lineage could be at the table level or at the field level or at the job level. It really varies by the use case. But the point here is that lineage helps you tie all of these together. What does that mean? That means that if you know that there's a freshness problem somewhere upstream, or there's kind of a schema change that you're making somewhere, you can be aware of all of the different sort of downstream implications, at sort of the tip of your finger. Oftentimes, we find that data downtime is a result of miscommunication between teams, and I'll talk about that in a second a little bit more. But Lineage helps sort of bring all of these pillars together, and tell us the story of what exactly broke and where, as well as identify once something broke, where exactly it broke, right? And so having an automated way to really understand your lineage is sort of key to kind of bringing all of this together. And so let's look at a couple of examples of what does data observability actually look like in practice. Those were sort of the 5 pillars. Now let's talk about kind of just a couple of examples of what it could look like. So as I mentioned, maybe the most common instance of data downtime is when someone makes a change which results in sort of missing or partial data downstream, right? Maybe, an engineer makes a change to a website, and then the downstream sort of marketing team is now working with incomplete data, because that particular event on your website stopped tracking. So data stopped coming in for that data. And perhaps you're using that data in order to make decisions for, a recommendation system. Potentially they're using that for better targeting and acquiring customers. And so, operating with this partial information means that they're basically, impacting the ROI of their marketing campaigns. However, how does data observability work in practice? If you overlay what we just talked about until now, and have this sort of lineage view and some color coding, red, yellow, green, to understand where there are problems, where red may indicate, okay, here I have a freshness problem, and here downstream, this resulted in distribution problem, et cetera, visibility into all of these dependencies of a particular field actually allows you to make changes faster, so since you know what are sort of all the things that rely on downstream. And so what we see is that the best teams actually use this automatically generated map of all the dependencies so that they can be aware of the impact of the changes that they're making. And that sort of allows them to move faster and spend less time worrying, or spend less time recovering from data fire drills. This is another example of what data observability looks like. Another sort of very common thing that we see is when, say your BI dashboard just hasn't been updated in 24 hours. And, you're unaware of that, unless you, manually specified to get an update about that report, it's really hard to know. But the teams that use data observability actually use machine learning-based detection of freshness issues, so that they have full coverage for the data assets and can get alerted in near real time. And so we see organizations invest in figuring out ways to automatically track some of these very common issues like data freshness. what you're seeing in this example here is actually a particular report that is delayed, and then all of its dependencies. Oftentimes when one report is delayed, everything else downstream is delayed as well. Then finally, the third example here that I'll show is that I mentioned data downtime very often is a result of miscommunication between different groups working with data, whether it's the various personas that we mentioned sort of at the beginning, whether it's data analysts, data scientists, or data engineers, which lead to modeling mistakes. And sort of often what ends up happening is sort of a data organization will come in the morning and suddenly there's this major model drift. Or unexpected results that they're seeing. The best teams that we're seeing use data observability to avoid that to begin with, and also deploy these techniques that I talked about in order to allow for faster triage and troubleshooting of data. Why? Because here's the deal: the longer that your data sort of issue lingers, the harder it is to actually backtrack from it. The harder it is to backfill the data. And oftentimes data organizations will learn about issues like months later or weeks later, if they're lucky. And so in that case, recovering from that takes a very long amount of time. And by thinking about data observability best practices and deploying them, you are able to, in a faster way, pinpoint the root cause and see, okay, this is exactly sort of the anomaly that happened. This is exactly the issue. And being able to sort of, rapidly triage and troubleshoot the issue. So these are just a few of kind of the data observability examples in practice. Hopefully, bring to light some, shared examples that you've potentially experienced and how data observability sort of really helps in practice. One of the things that I'm seeing more and more teams do is actually think about, okay, you might ask yourself, well, data downtime happens to everyone. What's the cost of this to our organization, right? Like, why should I care? Well, interestingly, as we talked about a little bit, data downtime has real implications on my organization. And here's how people are quantifying it today. This is what we're seeing in the market. There's three main ways. One is the amount of time that your engineering or data team spends on data issues. We've sort of used 30% here as a plug, but question for you and for your organization is, how much time are you all spending on data fire drills? And actually calculating that out can give you a good sense of sort of the labor cost. The second sort of main way is a compliance risk. Again, we plugged in here 4% of your revenue, given based on sort of GDPR in particular. But potentially your organization is required to comply with many other compliance and other regulations. And so, the impact may be higher than this as well. And then third is the opportunity cost. Your team and our teams, could have spent time generating revenue if instead of dealing with fire drills, you could have moved faster, released new product, work with new technologies that saved you more time, and acquired new customers, right? And so if you want to start thinking about what does data downtime mean in my organization, how do I unpack that? Start thinking about sort of these questions, right? Like, how often do we have data fire drills? Is it, once a day, once a month, once a year? And when these data downtime instances or issues occur, what is the impact of that on our business? How would we quantify that? And yeah, would love to hear sort of your stories and experiences with these. We're collecting more and more sort of data and information about this. One of the things, just kind of to spark some additional thoughts here that we're seeing sort of some of the best teams do is take this to the next level in the sense that not just start thinking about data observability holistically. Oftentimes people have sort of parts of the pillars, maybe they're just tracking, only sort of null values within the distribution pillar. Or maybe they're just looking at freshness for particular tables, right? So they might have, only bits and pieces of the data observability pillars. But what we're seeing is that the best teams have one full coverage of data observability pillars. So truly all of them, all the metrics in each of them. And then they take this to the next step. How do they take this to the next step? They actually create, sort of a data downtime dashboard that helps them see how they improve over time in this area. And this again draws on best practices from software engineering, where folks define metrics like SLAs and SLOs for for their own work. And so in the data space, we actually, many of our customers have asked us, like, how should we be tracking data downtime, right? What should be in our dashboard? And so, one of the things that we look at is the number of incidents, or the number of data downtime incidents that you have, times time to detection and time to resolution. And really, you can see that the best data teams, reduce the time to detection of issues, reduce the time to resolution, and with the right preventative measures, actually reduce the number of incidents to begin with, which is remarkable. So, when having the right data observability solutions in your hand and the right data observability information, you can actually prevent all of these to begin with. Like, how magical is that? How magical is a world in which we wake up in the morning and we just know we can trust our data? And we have the confidence to use that data to feed our products, to improve our businesses, to improve our lives, right? I really believe in us, making that a reality. And so that starts with applying some diligence to what data downtime is and how are we improving it. So in the last minute here, I'll just summarize some of the key takeaways that I talked about. First of all, as I mentioned, data downtime is, I think, one of the biggest challenge, or not the biggest challenge, that our industry is facing. This is not something that's new, but it's something that has exacerbated. It's something that will become even bigger in its importance, and something that we all have a shared responsibility to solve if we want to see the future of data and the future of our industry. The good news is that we can apply some best practices from software engineering. In fact, some things that were sort of purposely designed for these kind of problems are things that we can apply here, so we don't have to reinvent the wheel. And I'm happy to report that I've seen data observability alleviating the pain for data ecosystems in real time. Like, we're actually seeing this with companies who are driving this improvement. And so I'll leave you all with a parting thought. One in which, if you think about, the last couple of years and how we've used data, largely data has been confined to a small amount of data, to a small number of people, right? In most organizations, that you've potentially come from, maybe 5 to 10 years ago, there was a handful number of people, potentially in finance, potentially in IT, potentially in marketing, who were making decisions based on a sort of a limited set of data that they, potentially use to report, once a quarter. And so in that world where we had few people looking at small amounts of data and using it at sort of small intervals of time, or large intervals in time, we could deploy all of the sort of manual approaches that we had in the past to make sure that data can be trusted. That was sort of the old world. In today's world, we have way more data sources that we're managing. We have way more consumers of the data. We have thousands of people using data, in sort of some of the most forward thinking data organizations like Netflix and Uber. People are actually using, data in real time. Thousands of people are using data in real time. And so in that world, we're not going to be able to sort of rely on some of the manual approaches that we had. And in this new world, we're going to need to figure out some of these fundamentals. And as an industry, we want to figure out a lot of different things, and we want to use AI and all these different things. But if we don't nail these fundamentals, if we don't actually figure out how do we trust the data, how do we know where it came from? If we don't actually figure that out, we're not going to be able to move forward as fast as we can. So I'm excited about the application of data observability. I think it can unlock a lot of the value that data has to offer for us. And I'm really, really excited to see some of the results of this emerging new field. And looking forward to sort of spending more time on this and sort of Q&A or ask me anything session after this. Thank you so much for taking the time to listen. If you'd like to learn more, reach out. If you're interested in learning more about data downtime or data observability, or really just want to share kind of your personal stories about data, feel free to reach out. Thank you so much. Thank you again. It was such a pleasure to speak with you all today. And I hope you have a great rest of your day, and see you tomorrow at day 2 of the conference.